Okay, we're going to do worksheet 11 and 12 today. So I'll start with worksheet 11. So in the question, there was a graph given. So it was a straight line going like this, then something like this, a straight line going like this. And in the actual question, this continued even after, all the way to 7. And he said f of x equals f of x plus 2. Now, in the question, he wanted the Laplace transform for the function. Now, in my answer, I said, in this portion, where it's between 0 and 1, the function is t, because that's a straight line going up, equation is t. Then from 1 to 2, there is nothing, so I said 0. Then this line, or this function, it's a straight line like this, but there is a shift too. And after this, from 3 to 4, it's 0. I did this all the way to the end, but then in his answer, he only did the first 2. There was no indication in the question to just do the first 2, but my assumption, and I'm not 100%, because the same function repeats, you don't have to do it all. Since there is repetition, so the same thing repeats, you only do the first. That's the only explanation why he didn't do the whole thing. Now, to do this, since this is similar to the previous worksheet, since the first one starts from 0, you can just bring it down. Then this one, you say t minus 1. And for the function, you say whatever this one is, minus the one before. So this is negative t. I can take the constant out. That leaves me with t. The t, as you know, when you do the Laplace transformation, you need Laplace transformation for t and for this. Laplace transformation for t, you can look at the rules, but this is the, I believe, the second rule. It's the one involving the n factorial. So this one is 1 over s squared. For the unit, you basically say e to the minus s. So now you took care of the unit t minus 1, e minus s. The t by itself, we know it's 1 over s squared. What about the number? I told you the trick. The value of a is 1. So you add it to the number, which is 0, so it becomes plus 1. And the 1 has a transformation of 1 over s. So again, the number that we don't see is 0. You look at the a number is 1. You add it to whatever this number 0 becomes 1, and you do the transformation 1 over s. And again, why he ignored all of this to after, I don't know. We're going to do question number 2. The question A was t to the power 5 cosine t. Now, since this one is to the power 5 a bit too much, I just want to show the same idea, but I'm going to make it to the power 2. Now, this is what I told you. Diego did something strange in this worksheet. I don't know if he updated the answer. What he did for the transformation for this, he said the transformation for this, I'll take the transformation of the first one times this transformation of the second one. And that's wrong. When you have two functions multiplied, you can't take the transformation of the first one times the transformation of the second one. You can only do it if it's part of integration. Only if it's part of integration you can do it. But you can't do it in a normal question. You can't just say a function times a function is transformer first times transformer second. That's wrong. So he continued with this and he said transformation for t squared is like s3 2 factorial, and the rule for cosine, it was s squared plus 1s, and just continued with this where the fact 2 factorial is 2, you cancel s with s, so you have s squared. Well, but he did it for the t5, but again, he did it as product. Now, if you go to any website where you can allow the transformation, you're not going to see this answer because that's not the answer. In fact, we're going to use from this sheet rule number 15. Rule number 15 says when you have t to a certain exponent, in this case 2, you gotta take the transformation for this and then find the second derivative. So you transform this with the second derivative. And the sign will be negative 1 to n, which is negative 1 squared, which is positive, so it's not gonna matter. So we're going to take the second derivative for the transformation of cosine. Now, in the question when it was 5, the sign negative 1 to the 5, it was negative, and I took the fifth derivative for this. That's why the answer was long. So to take the derivative of this, so first of all, I need to find the derivative for this one. Applying quotient, derivative of the top times the second function, derivative of the bottom times the first function over the second function squared. So this is like s squared plus 1 minus 2s squared. This is like negative s squared plus 1 s squared plus 1 squared. This is the first derivative. I still need to take the derivative of this to get to the second derivative. So now we need the derivative of this. Derivative of the first one times the second function, derivative of the second function times first over the second function squared, so it becomes 4. So derivative of the first one times the second one, derivative of the second one involving chain rule times the first. Now let's see if we can simplify this. First of all, since this repeats everywhere, I'm going to cancel 1 from here, and 1 from here. Because you can cancel, because it's repeated everywhere. Take this one inside, minus 2s cubed, minus 2s, minus 2 times this is minus 4s, times this plus 4s cubed, and minus 4s times 1 is minus 4s, over s squared plus 1 cubed. So the second derivative, negative 2s cubed plus 4 becomes 2s cubed, negative 2s, negative 4, negative 6s over s squared plus 1 cubed. So the transformation, we know, remember, the sign positive, so it's not going to matter, and this is the second derivative. or you can take 2s as a common factor. That leaves you with s squared minus 3. Now if you go to any website, I can send you a link of one that does the transform. You'll see this as the final answer for the t cube, not this. This is the transformation. So again, product, you can't take the first one times the second one unless it was part of integration. And you'll see this when we do the next question. Now, for Laplace transformation, for integral, you only had maybe, I don't know, one question, maybe two questions, I don't know. But I'm gonna do, before I do the question you had, I'm gonna do examples. So, first example, what's the Laplace transformation when it's 0 to t e to the minus v dv? If you look at the rules, this is the operational rule. So we're not using number 16 because there is nothing minus. You don't have t minus v. So it's only the function with no shifting. There's no shifting here. That would be rule number, the first rule under operational laws. Or basically, no shifting. We'll call it no shifting. When it's no shifting, you basically treat this as t, and the dv you treat it as 1, and you do this product. So remember I told you you can only do the product when it's integration. Now you do transformation for this. This would be s plus 1, and the 1 would be 1 over s. So this is the transformation for the integral. I'll do another example. Zero t sine v dv. Again, you see no shifting. When it's no shifting, you replace the v by t, so it's like sine t times 1. And now you can do it as product. The transformation for sine and the transformation for 1. Of course, you can write this as s squared plus 1 times s, and you can write this as s plus 1 times s. So it's easy, it's not that big of a deal. Now, we'll do the one involving shifting. t, t minus v sine v dv. So now we see shifting. This is more like, this is rule number 16. When there's shifting involved, you treat this as the one with the shifting, you treat it as t. And this one as sine t. So this one you just treat it as sine t. The one with the shifting you treat it as t. Transformation, you can do it, sorry. You can do this now as product. The transformation for t is 1 over s squared. This is rule number 2. And for the sine, we've seen this so many times. And you can write this as s squared plus 1. Another question. V cosine t minus v dv. The v by itself we treated like t. The one with the shifting, you just call it t. You do this as product. The transformation for t is 1 over s squared. The transformation for cosine is this. You can cancel s with s, so final answer is this. Good? So now we can do the one in the homework worksheet. It was 0t e to the t sine v dv e to the v. By the look of it, you don't know, do we treat it as the one no shifting, or do we do it as shifting? Well, the trick here is e to the t over e to the v, because you know, when you divide similar terms, you can minus the exponents. So e to the t over e to the v is e to the t minus v, because dividing similar exponents, you minus exponents. Sine v dv. So again, it becomes like shifting, rule 16. For this one, it becomes e to the t, so you treat the one with shifting as e to the t, and sine v is sine t. Transformation for this, and transformation for this, you can write it as s minus 1 s squared plus 1. Good? Okay. Now, question 3 is to find Laplace inverse
Why should I charge it? Why should I charge it, Dina?
but they want you to do it by convolution, which is rule number 16. So he wants you to do it by using rule number 16. First of all, I'll do it the normal way. So we say it's s minus 5, partial fraction is this. This one has s, so it needs s minus 5. This one needs s. We try 0 to cancel. Minus 5a. A is 1 over minus 5. We try 5. We get 5b. So b is 1 over positive 5. So this one, negative 1 over 5 over s. 1 over 5s minus 5. To do the inverse for this, for the first one, 1 over s, we know that's the first one, so that's just 1. And for the second one, s minus 5, that's e to the 5. So the answer is negative 1 over 5 plus 1 over 5 e to the 5. That's the final answer. Or you can write this since they share the same exponent, denominator, sorry. You say 5 and negative 1 plus e to the 5. Either way, you're good. But that's if you do it the normal way. To do it using convolution, I'll show you, the rule itself is strange. So this is rule 16. When you have integration 0t it becomes f of s Now remember, we're doing inverse, so we need to go from here to here. It's inverse. So I have it in terms of s, but I have to make it the product of two groups. Okay, so that would be 1 over s and 1 over s minus 5. I need to do the inverse for both of them. For this one, 1 over s, that's 1. For this one, it's e to the 5t. So now I was able to go, this one, I made it two different functions, multiplied, I did the inverse. Now I've got to make it as an integral. The first one is just 1, so just write it. The second one is e to the 5t, but instead of t, I put this, so it becomes t minus this. And you can, it doesn't matter what you call this simple. You can call it v, call it anything. I think he calls it v. So now I'm integrating this. But in terms of dv, and of course the one you can ignore. And remember, it's in terms of v, the integral. To integrate this would be itself over the multiplier in front of the v. And the multiplier in front of the v is negative 5. So the integral of e would be itself over the multiplier that's in front of the variable, which is negative 5. Now you plug t, you plug 0. If you plug t, it will be e to the 0, 1, so you have negative 1 over 5. Minus, you plug 0, but minus and minus turns into plus. You plug 0, it becomes 5t minus 0, or 5t over 5. And if you see, that's the same answer we got when we did it the normal way. So again, when you replace it by t, it becomes e to the 0, 1 over negative 5, minus turns into plus, and you put 0, becomes 5t over 5. This would be the first part. Or you know what, maybe we can finish the assignment here, and then second one would be for the worksheet 12. Question 4. Is solve the differential equations y prime t minus 2 integral 0 t y of t minus v ev dv equals ETT, and y at 0 is 1. So we're solving, so we're going to solve it using Laplace. We'll do the Laplace for y prime t minus 2 Laplace for the integral Laplace for this. Okay? Laplace for this one, you know the rule. You go s, y of s minus y at 0. Laplace for the integral, I told you, you treat t minus v as t, and this would be e to the t. Laplace for this here, you cannot do it as product because it's not part of integral. So you have to use a rule. For this one, we'll do 11. The way to do it is there's a shifting of 1 and the t. So the t is 1 over s squared. But instead of shifting 1, it becomes negative 1 s squared. And I believe that probably in other tables, you might see something for this right away, for other Laplace tables. So, but the way we do it, we do the t first, 1 over s squared. There's a shifting of 1, so you go s minus 1 squared. Y at 0 is 1, so you have s, y of s minus 1, 2. Now here, since this is part of integration, you can do it as product. The yt transforms into ys, and et transforms into 1s minus 1. Okay, we continue with this. Take the 2 inside, so you have 2ys when you multiply over s minus 1, because these two are multiplied. And here you have 1 over s minus 1 squared. Okay. I'll bring the 1 over, so we have this 2ys over s minus 1. You bring the 1 over, plus 1. So all I did is bringing the 1 here, negative 1 over. Now, still, I need to get rid of s minus 1. So I'm going to multiply both sides of the equation by s minus 1. Here, this times s minus 1 becomes s squared minus s into y of s. This time the 1 cancels the bottom, so you have minus 2y of s. And this times s minus 1, you cancel one of the 1's in the bottom, and times 1 becomes s minus 1. I take ys as a common factor. This leaves me with s squared minus s minus 2 minus 1. This can be factored. S minus 2, s plus 1. 1, s minus 1, s minus 1. So a lot of factoring and stuff involved. In the next step, your y of s, you take this on the bottom, s minus 1, s minus 2, s plus 1. For this one, s minus 2, s plus 1. For this one, s minus 2, s plus 1. We can combine them into a common denominator, all of them. For the first one is 1, no problem. But for this to match this denominator, the s must be multiplied by s minus 1. For the -1 to match this, it needs to be multiplied by s minus 1 as well. This is 1. This is s squared minus s plus 1. The final results for this is s squared 2s plus 2 over s minus 1, s minus 2, s plus 1. We can do partial fraction now. A over the first one, B over the second one, and C over the last one. So you have s squared 2s 2. This one needs s minus 2 and s plus 1. This one needs s minus 1 and s plus 1. And C needs s minus 1, s minus 2. We try numbers. I'll try 2 first. 2 here gives me 4 minus 4 plus 2. 2 cancels these 2. I have 1 times 3, 3b. So b would be 2 over 3. We try another number. We try 1. That's 1 minus 2 plus 2. 1 cancels these 2. Here, I have minus 1 times 2. That's like 1 equals minus 2a. A is minus half. We try another number. Try minus 1. Minus 1 squared is 1 plus 2 plus 2. Negative 1 cancels these 2, and here we have minus 2 minus 3. This is 5, 6c, c equals 5 over 6. So at this point, I know that my y of s is a is minus half, b is 2/3, and c is 5 over 6. We can do Laplace transformation that will lead us to the function. For the first one, there is a constant, and this one is e to the t. Constant, e to the 2t. Constant, e to the minus t. So this is the Laplace transformation, or the solution for the dE. This is all for worksheet 11. In the next video, I'll go over the last worksheet, worksheet 12. Okay?